Okay, let's take a look at this problem from 2007. Number 3, lots of theorems, table of values given. And this problem is historically one of the lowest or the hardest question ever asked on the AP exam. I shouldn't say historically, statistically speaking. The average score in 2007 for AB students was less than a 1 out of 9 on this problem. And it was not on the BC exam. So we don't know how the BCs would have done. But we have a table of values for f and g and their derivatives. They do tell you that f and g are differentiable for all numbers. G is strictly increasing, and the instant I see that, I like to make notes as I read. If I see a reference to anything increasing, my first thought is that that thing's derivative must be positive, and that is a true statement. However, as we work this problem, you'll realize that that piece of information never does come into play. They just gave that to you as a distractor. The table gives you values of each function and their derivatives, and then they introduce a third function, h. So let's make it even more difficult. We already have f and g, but here is a function h, and questions A and B both reference h. And the first question, we'll talk about both of them right now, actually. The first question says, explain why h is equal to -5. And the second part B, asks why h prime is equal to -5. The only good thing about these questions is that they tell you it does happen. The question is, explain why there must be a value r such that. The question doesn't ask, is there a value? We know it happens, we just have to explain why, and that is usually done through a theorem. There are other ways, but in these two cases, we will use a theorem. If you are ever asked to show that the function equals something, I'm going to start with the intermediate value theorem. If that fails, then I may go through another approach. And for part B, it asks, does the derivative equal a value? And when it asks to justify or explain derivative values, then you want to go with the mean value theorem. So what I'm going to do for part A is, my daughter wants to play Minecraft some more on her iPad. Hang on. Okay, so I completely lost my train of thought there. So we're going to show part A with the intermediate value theorem, and we're going from 1 to 3, and I'm trying to guarantee that h is equal to -5. So I'm really curious, what is h of 1 and what is h of 3? If we are lucky, then h of 1 would be on one side of -5, and h of 3 would be on the other side. So let's see if that happens. Here's my function h up here. H of 1 will be f of g of 1 minus 6. G of 1 is 2, so that's f of 2 minus 6. F of 2 is 9. 9 minus 6 is 3. Okay, so that is greater than -5. And then let's find h of 3. That's f of g of 3 minus 6. G of 3. G of 3 is 4. So f of 4 minus 6. F of 4 is -1. So -1 minus 6 is -7, and that is less than -5. And that is what I wanted. I wanted to go from one side of -5 to the other side of -5. And because the functions are differentiable, then we know that they are continuous, which is the requirement for intermediate value theorem. So I'm going to take that information, and I can say that since h is a composition of f and g, and f and g are both continuous, then h of x is continuous. You must lay out the requirements for each theorem, and for the intermediate value theorem, you want to show that the function is continuous. H is continuous. H of 1 is greater than -5. H of 3 is less than -5. Therefore, the intermediate value theorem guarantees that h of r is equal to -5 for some r between 1 and 3. And so there's your answer for part A. Okay, so for part B, explain why there is a value c such that h prime is equal to -5. And this one, we're going to go mean value theorem. And this if you think to use the right approach, this one's actually pretty quick, because the mean value theorem, you're going to find the slope from point A to point B. And we have the ordered pairs for x equals 1 and 3 right here. We did that in our work for part A. So according to the mean value theorem, if a function is differentiable on the interval 1 to 3, which they do tell you that f and g are differentiable, therefore h will be as well. So I'm going to establish my groundwork to use the mean value theorem. H is differentiable. And I'm lazy. I'm going to write that as diffable. I wouldn't do that on the AP exam, but I'm saving time here, and I just negated the saving time by explaining that I'm saving time. Take that. All right, so h is differentiable on the interval 1 to 3. Therefore, the mean value theorem guarantees, and it is okay to use abbreviations. You can say MVT on the AP exam. The mean value theorem guarantees that h prime of c is equal to h of 3 minus h of 1 over 3 minus 1 for some c on the interval 1 to 3. So I'm going to keep going with that. H of 3, looking up at part A, was -7. H of 1 was 3. 3 minus 1 is 2. 7 minus 3 is -10. Divided by -2, but divided by 2 is -5. And that is what we wanted. So there is our proof that there must be a value c such that h prime of c equals -5. Those are the two. I don't know. I think those are the two harder ones. Y'all may think D is more difficult. Let's talk about C. C is, in my opinion, the easiest. They introduced a fourth function, W, and W is an integral defined function, and they want the value of W prime of 3. So I'm going to start by establishing what W prime of X is. This question was a calculator active question. However, the calculator is not going to be of any use whatsoever. Typically, if you have a calculator and you see W prime of 3, you'll use your derivative at a point command and you'll just throw it in the calculator. But that only works if you have an explicit function equation for your functions, and we don't have that. We don't know what the equations are for f, g, h, or w. We just have it in generic terms. So we're going to have to actually write the derivative first, and when you do the derivative of an integral defined function, you want it to be from constant to variable, which it is. We're going to plug the g into the t, and so it's going to be f of g of x. We replace the t with that upper limit that's in terms of x. Then you have to remember to multiply by the derivative of what replaced the t, and that's the step most people will forget. Okay, so then I'm actually going to make a point here. I'm going to write equals. That's wrong, but I'm going to explain why in a minute. This is what's called a linkage error, and I want to show you what would cost you a point on the AP exam. So we have the correct derivative, and then my next step is to plug in 1. I want to find W, not 1, I want to find W prime of 3, which would be f of g of 3 times g prime of 3, and then we'll look at the table to figure that out. So g of 3 is 4. I'll leave g prime of 3 alone for now. F of 4 is -1. And g prime of 3 is 2. And so you get a value of -2. And this is full understanding of the process. We found the derivative correctly. We plugged in 3, and we evaluated and got the correct answer of, I'm double checking my work. We got the correct answer of -2. However, right here, I made a mistake that is very common on the AP exam, and you have to be careful when working from left to right. I put an equal sign right here, which implies that W prime of 3 is equal to f of g of x times g prime of x, and it is not. W prime of 3 is equal to what happens when you plug 3 in for the x's. So be very careful with your equal signs. That should not be an equal sign. It should be, if anything, just leave it blank. Just don't put anything. And on the AP exam, you have plenty of work. I would probably just start W prime of 3 underneath this. But if you work from left to right, in this case, at most, put an arrow. This derivative leads to the next step of plugging in 3, and you get a value of -2 in the end. And then there's part D. If G is the inverse, G inverse is the inverse of G, write an equation for a line tangent. That phrase should immediately make you think that you need a point and a slope. Okay. And the thing is, we're doing the tangent to G inverse of X. So my point would be G inverse of 2, and my slope is going to be the derivative of G inverse of X at X equals 2. Now, G inverse of 2 is not too hard to do, but it's easy to screw up. G inverse means you read the table backwards. My G function is equal to 2 at X equals 1. And so since G of 1 is equal to 2, that means that G inverse of 2 is equal to 1. So I'll go back down here. G inverse of 2 is 1. Therefore, my ordered pair for this equation is going to be 2, 1. And my slope, the derivative of an inverse function, I teach this with a memorized formula, which I'm not too fond of just memorizing formulas, but it comes in handy. The derivative of an inverse is 1 over G prime of G inverse of X. And so if I want this at X equals 2, that would lead to 1 over G prime of G inverse of 2, and then we figure that out. G inverse of 2, we just found out was 1, so 1 over G prime of 1, and G prime of 1 back up to the table is 5. And so I have a slope of 1/5. And then finally, the little bitty tiny step, the equation of a line, I like point slope form. Y minus 1 is my slope, and it does ask for a tangent. Make sure they don't ask for the normal line in which you would do the negative reciprocal, but it's y minus 1. Y minus y coordinate is slope times x minus x coordinate, and stop there. There's no need to turn that into slope intercept form. Point slope form is perfectly acceptable, and that is all 4 parts of, statistically speaking, the hardest question ever asked on the AP Calculus AB exam.